Hi everyone, welcome to another part of our data analytics techniques series. So today we'll be talking about important subcategories to learn as data analysts, types of variables, type of analysis, and type of statistics. If you've not watched the previous videos, I really encourage you to pause this video right now to go watch the previous videos because we are building up on the previous videos. So where we already talked about what is a variable and what is its statistics. So we just want to visit what are the important subcategories that you should know as a data analyst. And so one of it is type of variables. Just to bring to memory again to let us know what a variable is. So a variable is characteristics that can be measured or vary between entities, typically represented by column heading, sex, age. So basically, when you collect your data and what you collect from people is most times referred to as variable. So just think of like the columns, like the headings are what you have as variables, sex, age, income. So what are the types of variables that we have? So we have numerical variable and we have categorical variable. So numerical variables, these are variables that represent quantifiable counts. They can take on numerical values or typically used for numerical calculations. So the way the name sounds like numerical, it sounds like numbers. So they include variables like age, height, weight, temperature, income. So variables that are like in numbers that has decimals, so they are called numerical variables. There's a caveat to what I said, but I'm going to tell us what that means as I go into categorical variables. So categorical variables are variables that represent groups, so they can take on issues that represent different levels or labels, but those values don't have mathematical meaning. Example, gender, marital status, type of car. So these are variables that you can think of as they are in categories, not that they're in numbers. So we're going to show us examples so that we can have a better context of what numerical variable and categorical variable is. So under numerical variable, we still have two types of numerical variable. We have three types of categorical variables. Numerical variables. So the first type of numerical variable that we have is a continuous numerical variable. So these are variables that take on any value within a range. They are typically measured and can have an infinite number for positive values between any 2 points. So examples include height, weight, temperature, and time. So think of it as numbers that could have decimal numbers. So you have your heights could be 5 point something, your weights could be in decimal, temperature could be in decimal, so time. So numbers that are continuous. Why another type of numerical variable is a discrete numerical variable. So discrete variables are variables that can only take on specific values within a certain range, typically whole numbers or integers. Example include the number of children in a family, the number of cars owned. So think of numbers or characteristics of variables that can never be in decimal. So those are discrete numerical variables. So you can have 3.5 children. You can have 2.5 cars. So you can either have 1, 2, 3, 4, but you can have 2.5, maybe 4.5 height or 4.5 weight. So those are numbers that could take on like decimal places. So just think of it as a better way to differentiate between a continuous variable and a discrete variable. However, most times when you run your analysis, so the types of analysis that could typically work for a numerical variable, for a continuous variable, might work for a discrete variable. It's just very few analysis that probably you might not want to run for both. So, and it's very important that when you see your data set or you see your variables, you're able to recognize quickly, is this a numerical variable or is this a categorical variable? So that could give you like a sort of direction into like how you understand like your analysis and stuff like that. So the types of categorical variable that we have binary variables, we have ordinal variables, and we have nominal variables. So what are binary variables? The way the name sounds, binary sounds like something that is two. So these are categorical variables that only have two distinct categories or levels. So these categories are often represented as 0, 1, yes or no. So example is, I mean, right now, that's why I'm using gender, but we know like if I was supposed to use sex, we have more than two right now. So for gender, that is gender bets. So it's either you come in as a male or you're a female, or is either like maybe somebody asks you a question and all the option you have is yes or no, not maybe. So that's binary. So it means when your categories, the levels are two. So what, let me repeat that again. So if you are asked a question and it's a categorical variable, so yes, it's a level, no, it's another level. So if you have just two levels, they are called binary variables. So know how these terms are used interchangeably. So I have two levels, that means they are is a binary categorical variable. So ordinal variable. Before I go into ordinal variable, so you notice that for example, somebody can ask you, or in a data set, they could represent one as yes and represent two as no. Actually, that is a number, but in a real sense, they are not representing one and two as numerical variables or continuous variable. They are presenting one and two as a categorical variable. So that is why you need to check the code book to know that one and two doesn't mean you are supposed to add them up together for you to get three. It's just supposed to tell you that one represents male and two represent female. So that is a caveat. So not all numbers are numerical variable when you see them in your data sets. So you need to be careful, especially when you look at like the variable name and you when you think about this with this variable, would this actually be like a categorical variable or a numerical variable? Also, you could convert like you could convert a numerical variable to a categorical. So one way to do that is, let's say in your data set you are giving like an age, so they collect people's age like 16, 17, 20, 21. So maybe when you want to start your analysis, you could group people that are within less than 18, you put them in a category. People that are 18 to 20, you put them in that category. People that are 21 and above, you put them in another category. So that is you converting a numerical variable to a categorical variable. So that's like part of like your data manipulation processes. But for now, let's just sort of stick to like our explanation of numerical variables and categorical variable. So another type of categorical variable that we have is ordinal variables. So these are categorical variables where the categories have the most natural order or ranking. So these intervals between the categories may not be equal, but there's a clear ordering from lowest to highest. So example include satisfaction level. So that is somebody says low, medium, or high, or economic status. So that's like low, mid income, middle income, high income. And that thing is also when you rate a product. So let's say you give it a 5-star rating, another person give it a 2-star rating. So in your analysis, on your interpretation, so you need to know, is this variable like a ordinal categorical variable? So that would sort of help you to interpret your result well, knowing that 5 and 2, these numbers are like bigger than each other, or they are different in ranking. Actually, 1 can actually mean the best number and 5 can mean the worst number. So that is why you still need to go back to your code book. So because if somebody says yes and no binary, it doesn't mean like yes is better than no, or no is better than yes, or agree is better than disagree, or male is better than female. So that is what like the binary variable like does. So there's no ranking, but for an ordinal, so the way you see is like there's an order. So the order at which the number appears really matters. So you can't just rearrange in whatever order you think. So in nominal variable, it's more like the binary variables, but it's just the fact that you have more than two levels. So like these are categories that represent groups with no inherent order or ranking. So it's like I have I like this the colors include red, blue, green, orange. So I have fruit, apple, orange, banana, marital status, married, single, divorced. So it's similar to the binary variable, but it's just that like most times you could call like a binary variable a nominal variable, but like for sake of clarity, when you have more levels, so they are called nominal variables. So like I said, some of the analysis you could run for a categorical variable might work for all these type of categorical variable like binary, ordinal, nominal. But sometimes analysis are actually specific to one another. So remember the types of variables are numerical and categorical variables. So let's look at an example of a numerical and a categorical variable. So I kind of made this kind of clear. So these two colors, so these two are numerical variables, and the ones that are not in colors are the categorical variables. So but this is a continuous numerical variable. So you see income. So somebody could actually earn in let's say I don't know what currency this is, but could also earn in cents or so that's like let's say $7,890 34 cents. So but this is a also a continuous, this is also like a numerical variable, that this is discrete. So it means that like somebody can have 3.5 children or so. So we have 2, 3, 5, 0 for categorical variables. So the first one here is we have a binary categorical variable. So it's just male, female, male, female. And the other one here is urbanity. So it means ordinal. It means rural. So this is also like we can call this like a binary also, right? So this is rural, urban, rural, urban, rural, urban. So is it that you are in a rural place or you're in an urban place? So why this is a rating. So somebody rated 1, somebody rated 5, others rated 2. So because this is number, you won't automatically say, oh, this is a numerical variable. So this is a categorical variable in this context. Why nominal variable is, so we see somebody has married, divorced, married, single. So you have more than like um two like levels, or that's what I'm gonna call it. So this is a nominal variable. This is ordinal variable. This is binary. This is binary. You could also call both of these nominal. It depends on how you want to call them. And this is a discrete continuous variable, and this is a continuous. So this is a discrete numerical variable, and this is an a continuous numerical variable. So it might take a while. You probably have to like get to watch this again so that you could familiarize yourself with the term. I know. So remember, this is another type of variable. So you might wonder, like we just spoke about types of variable. What do you mean this is another type of variable? So one thing about like data field is like there's really no same one way route to mentioning stuff. Most times the context at which you're explaining is very key. So if you go to Google and search for types of variable, you would probably see different things come up, but you just need to understand what this term means when somebody is speaking. We spoke about like some of these types of variables previously. So this is like sort of like another context, but they are also called variables. So so we have dependent variables. So dependent variables, these are like its outcomes or response that may be influenced by changes in the independent variable. In other words, they are the effects in the cause and effect relationship. So just like we said, so somebody who doesn't have a lot of money will probably not be able to afford to buy something. So the dependent variable here is not being able to buy something, why the independent variable here is like being broke. So this is just like the old differentiation between independent variable and dependent variable. So for you to understand the real difference between dependent and independent variable, think about cause and effect. What would actually cause this thing to happen, and what would be the effect or the result? So anything that's the cause would sound like the independent variable. What would be the result or the effect would sound like a dependent variable. And you really need to know this when you are trying to do your analysis or trying to make some interpretation. So why mediating variables? So these are variables that provide insight into the mechanism or process through which the independent variable influences the dependent variable. So think about cause and effect, right? So we know that people will, most times people die, like there's a high crime rate um when people go to the beach, right? So but that is actually happening because of the weather. So the weather, that's like because it is summer, right? It's like the mediating variables. So the mediating variables are like variables that help the cause to actually affect the effect. So those are the variables that like, so they are the variables within between here that like, oh, you need this cause needs that variable for them to be able to like work on the effect. So moderating variables, these are variables that affect the strength and direction of the relationship between the independent and dependent variables. So let me show you an example so you could have a perfect picture of what I mean. So let's identify the dependent, independent, mediating, and moderating variable here. So somebody says that there's an association between ice cream sales and death rates. So this year right now, the ice cream sales is usually like the independent variable, while the death rate is the dependent variable. A quick way to understand the independent variable and dependent variable, most times when people phrase a sentence, they talk about the independent variable first of all before talking about the dependent variable. But like you could find people who would twist it around. So also when you want to phrase your sentence, you have to phrase it such that your independent variable is going to come before your dependent variable. So it says that there's an association between ice cream sales and death rates. So the dependent variable here is death rate, which we also call Y as a symbol, while the independent variable here is ice cream sales, also known as X. So the mediating variable, the way in which ice cream sales can actually affect death rates is the time of the year or people visiting the beach. So they could also call this Z. So, however, the moderating variable means that this is different, or this relationship here is different for by gender or different by wealth status, meaning that actually people that would be more likely to die during the summer or more likely to die because of ice cream sales are probably, let's say, more males because they are the one who would engage in more of risky behavior, or based on wealth status because they are the one who is people who are rich that could actually go to the beach to have fun. So those are like the way you kind of speak about things. And this idea gives you like, oh, so if we want to sort of work on an intervention, we can know which sect we are supposed to focus on. We know that, okay, we need to focus more on gender, we need to focus more on wealth. Also, we also need to focus on the time of the year. So that means for us to solve this chaos of death rates. So you see, this is like an holistic picture in solving a problem. So, and the terms here are just like the terms you use when you want to explain to someone, but like in solving a problem, you might not need to really use all of these terms, right? So another subcategories we have is types of analysis. So types of analysis, just to remind us what is analysis. Analysis is any process of making sense of data. So we have quantitative analysis and we have qualitative analysis, and we do have mixed method. So quantitative analysis, so this involves analyzing numerical data to understand pattern or relationships. So when we mean numerical data, not necessarily data that are like, oh, numeric categorical, then categorical is not quantitative. That's not what this means. Basically, in this like course of this learning or in this series, almost all the things we'll be talking about, or most of the principles that we'll be sharing would be more of quantitative analysis. So when you can quantify things, I think that might not be the right word, but like that's like quantitative analysis. So why qualitative analysis? This analysis explores non-numerical data to understand experiences or meaning. For mixed method means that you are combining both. So you are combining quantitative and qualitative approach. So the tools for you to understand like quantitative analysis is like for you to carry out quantitative analysis include Excel, Power BI, R, Python. So when you use all of these tools for your analysis, most likely the type of analysis that you are doing is quantitative. So it's quant. So why if you are using tools such as Atlas TI, NVivo, MS Word, I would say qualitative. So you might ask a question is what about complexity? Some people might actually enjoy quantitative analysis compared to qualitative analysis. For qualitative analysis, it's very simple to learn. If you are someone who is intuitive, you can learn it in like maybe a month or so. But for quantitative, there's just so many things to learn when it comes to the wide range of usage. So most companies, most organizations will use quantitative analysis compared to qualitative. Qualitative is like an analysis that's qualitative. The one you use at last year, it takes a longer time to run an analysis. Um, but like for quantitative, it might not take as much time at all. So, let's give a practical example of a quantitative and qualitative analysis. So you ask a question from your respondent. So respondents are people who respond to a survey or response to a set of questions. So you ask a question from your respondent, what is your rating of this product? And you give them an option that says above average, below average. So that is quantitative analysis, meaning that you can sort of categorize, you can quantify, oh, 20 people said above average, 30 said average, while 50 said below average. However, if you ask phrase the question such that what is your opinion about this product? So you're asking them like an open-ended question. There's no like options for them, and they start to say, "Oh, I love this product. The only thing I think that this product should remove is this and this," and they're writing their reviews on the product. So that is qualitative analysis. So you see that for qualitative analysis, you might get more context into what the um like the respondents are saying, but for you to analyze that, then it takes some process. Like it takes you time for you to basically read through what everyone says, then use some thematic analysis to like categorize them, then write a report on them and say, okay, this is what majority are saying. I think that's the whole idea behind qualitative. But like I said, we are going to be sticking to quantitative analysis. If it's something that interests you, you could go up online and read up more about it. It's also a field you could explore as a data analyst. So we have levels of analysis. So levels of analysis include univariate, bivariate, multivariate. So univariate, bivariate, multivariate. So for univariate, it's basically you analyzing one variable at a time to understand its distribution. It doesn't consider relationship with other variables. So meaning if you want to check sex, it's just sex alone. You don't care about any other thing. So bivariate analysis, the way it sounds, it's like explores the relationship between two variables to determine if there's a relationship, an association, or a correlation between them. While multivariate analysis examines the relationship between three or more variables simultaneously to understand their pattern. So why do I need to care about all of this thing? Because when somebody wants you to run an analysis, most times, like if you would actually have to combine multiple variables together, for one result means that takes more complexity. So the order in the variable, that means univariate analysis might be simpler to run compared to a multivariate analysis. So let's try to identify univariate bivariate and multivariate analysis here. So going back to our data that shows us numerical and categorical variable. So in the question here, it says, what is the average income? So you notice that this question is just talking about one variable. So if you find the average or the mean income here, so what you just did is a univariate analysis. So then another question says, what's the average income by gender? So that means that is a bivariate analysis. So you are looking at two variables altogether. Then another question says, find the average income by marital status and urbanity. So right now we are doing multivariate levels of analysis. So in data analysis, another word for by is group. So when you hear by, just know that most likely they're asking you to divide something in groups, and most languages, most analysis software, they actually use group or group by when you want to do something like a categorical variable. So, but right now we are not talking about the practical section, we're just talking about the techniques so you could understand when you eventually run your analysis. So this is an example of a univariate, a bivariate, and a multivariate analysis. So types of statistics. We have descriptive statistics and inferential statistics. So for descriptive statistics, summarize and describes the main features of a data set. They provide insight to the data. Descriptive statistics include measures such as mean, median, mode, range, standard deviation, percentile graphs, dashboards, etc. Inferential statistics involves making inferences and prediction about a population based on a sample of data. Inferential statistics include techniques such as hypothesis testing, regression analysis, and all. So most times what people do is basically descriptive statistics. So descriptive statistics is that tell me what this data is saying. Tell me what is the level of the number of customers that we have. Tell me who is purchasing our product more. Tell me if you are making loss or not. All of those are descriptive. You are showing what the data is saying. Why inferential statistics means that like based on what this data is saying, what does this data sort of predict? It's like making an inference, or based on what this sample is saying, what do you think is going to be when everyone gets this result? So it's like basically trying to say, okay, for the small population, what would be the results for everyone? Or also, based on what we have right now, the trend, what would happen in the future? So making inferences. So that is a little bit you going beyond what your data have, information your data have, to sort of make a prediction. Not limited to that, it's part of what you do for inferential statistics. All of this can be called exploratory analysis. So when somebody says, oh, I want to do an exploratory analysis, don't allow those terms to make you throw your balance. What they are saying is they just want you to do an analysis to show something descriptive, to show something inferential. So the next is, so let's show us an example of descriptive and inferential. So it says find distribution of gender and average children born. So this is just basically find children, number of children, and also distribution of gender. So somebody says, what will be the predicted number of children for married women earning $15,000? So right now, the income, we do not have an income of $15,000. We have and we do not have someone who is married, who is earning $15,000, and who is a female. But with this data, we can sort of do some analysis that would predict almost accurately what would happen to a woman, what would be the income of a woman earning, what would be the number of children to a woman earning $15,000. So in this context here, right, we notice that you see that the outcome variable is like the number of children. So we want to know what will be the number of children. So the main variables that are predicting it is like the income. So we just wanted somebody who has 15,000 here, want somebody who has female here, and want somebody who has married here. But we don't have that. So doing like inferential statistics will give us that number or a close number for us to know what would be the number of children somebody who wins $15,000 would give birth to. So that's like a way to get to understand that. So another subgroup is for you to know sources of data. So sources of data refer to the origin or location from which data is collected or obtained. So they include primary data, secondary data. So primary data refers to data that you collected firsthand by the researcher or by an organization. So secondary data refers to data that's been collected by someone else, but analyzed by a different person. So this data already exists and is available from sources such as government publications, industry reports, websites, or database. So let's try to identify a primary and secondary source of data. So if I go to one of these links. And so these are the links you could actually source data for. You could take a screen munch of these to get off to sort of like know like links you could get data for free. So if you go to one of these links or your friend has collected the data and you use that data for analysis, so that data to you is a secondary data source. But imagine you create a Google form and you collect data for analysis yourself, or like you collect data from people, either in social media page or whatever means. So that data for you is called a primary source of data. So this is just a conclusion we done. So it says, try to ensure you read more, you familiarize yourself with this explanation. And like we always say, like a journey of 1,000 miles start with a step. So be curious, set goals, and remember that you can do this. If you want to learn more, kindly follow us on our YouTube channel and share to your friends. Turn your notification bell so you won't get to miss any of our amazing content. And so way to say thank you to us is to follow us on LinkedIn, Instagram, and Twitter at Velonti_VT. Thank you. See you in our subsequent videos.